Hello everybody. This time we're going to cover probability questions. Okay. Probability questions are generally written as if something statement, then what is the probability of something. Okay, normally written like that. Of course, sometimes before in here, they may give you some situation or environment. Okay. And you just calculate, then something will be numerator, and the if statement will be a denominator. What does it mean that? That is, okay, let's go over with example 1. There are 4 cats and 5 rabbits. If you choose 3 animals from these 9 animals, then what is the probability of choosing 1 cat and 2 rabbits? You understand, right? 4 cat and 5 rabbit, total 9 animals. And from here you choose 3 animals randomly. Then what's your chance you get 1 cat and 2 rabbit? Okay. You understand, right? Got it? If you're not sure, stop video and read it one more time. 4 cat and 5 rabbit, total 9. From here you choose 3. Then what's your chance of getting 1 cat and 2 rabbits? Okay, normally probability questions written if statement. In this case, if you choose 3 animals from these 9 animals, then what is the probability of choosing 1 cat and 2 rabbits? Thus, we just need to find how many different ways if a statement can happen and how many different ways then statement can happen. Okay? How many different ways can you choose 1 cat and 2 rabbits? Okay, 1 cat and 2 rabbit means from 4 cats we choose 1, and then from 5 rabbits we choose 2. Okay, then the calculation wise, 4C1 is a form. Do you remember combination? How do you calculate the combination? From here you multiply this many numbers, 1 less each time. Okay, so 5C2 is 10. Why? From 5 you multiply down 5 and 4 divided by from 2 to 1, then 10. And then for denominator, you calculate from 9 animals, you choose 3 randomly. Then if you calculate, it will be 84. Okay, combination and permutation and factorial. For those problems, you have to review completely. Okay? It's a very common symbol, and you will use it so many times, maybe during your whole life. Okay? So don't forget, memorize this one. Okay? Okay, let's go back to the question. Thus, the probability of getting 1 cat and 2 rabbits when you choose 3 animals from 9 animals is probability of 4C1 times 5C2, which is from 4 cat 1 came out, from 5 rabbits 2 came out when you choose 3 from total 9 animals. Okay? Then 4C1 is 4, 5C2 is 10, and then 9C3 is 84. So 4 times 10 will be 40. Okay, before that we better simplify first. 4 and 84 cancel, then it will be 21, right? So 1 times 10 will be 10, and 21, 21. So the chance will be 10 over 21, or you just divide to get decimal. Once you have a decimal, you can change into percent directly, right? So if you calculate approximately like 49 some percent. Now, example 2. There are 3 red marbles and 4 blue marbles. If you choose 3 marbles randomly, what is the probability of getting all 3 blue marbles? you have 3 red and 4 blue marbles. When you choose 3 from this total of 7, you have all 3 of them are blue. Means what? From 3 red you don't get any, but only from 4 you choose 3. Okay, this special case. When you choose 3 from total of 7. So calculation wise 3C0 is 1, 4C3 is 4. 7C3, if you calculate, come out 35. So the probability will be 4 over 35. So if you calculate maybe approximately like a 12 point or like a 13% somewhere around here, okay? You just use a calculator if they ask you percent. Or sometimes probably you can answer with a fraction like this. Okay, now example 3. There is one round table with 5 chairs and there are 2 girls and 3 boys. When they are sitting around the table, what is the probability that 2 girls sit next to each other? You remember, around the table in how many different ways? Then we have to ignore 5 starting points. That's why 5 minus 1 factorial different ways they can sit around the table. Okay, you remember, right? If you don't remember, go back to my previous lectures and you find out. If we name 3 boys A, B, and C, and 2 girls D and E, when they sit around the table, D and E must come together as one group, like one group. But one group can be DE or ED, 2 different possible ways. Thus, in for 1 factorial times 2 different ways with the 2 girls sitting together. Okay? So you just calculate. When all 5 of them sit around the table, and then 2 girls come together, DE or ED. Okay? The order doesn't matter. So using this data, we get the probability as P equal 4 minus 1 factorial times 2. Remember, DE or ED, 2 different possible ways is acceptable. So 4 minus 1 factorial. So to calculate, 4 minus 1 is 3, 3 factorial is 3, 2, 1, times by 2, 5 minus 1 factorial means 4, 4 factorial 4, 3, 2, 1 in multiplication form. Now, 3, 2, 1, 3, 2, 1 you can cancel, or you multiply all of them, but either way, right? Then anyway, eventually you have 1 over 2 if you simplify all of them. Okay. Now number 4, this one is actual probability problem for math contest preparation student. Okay, let's see the question. In the figure to the left, there are 3 red marbles and 3 blue marbles in jar A, and 2 red marbles and 4 blue marbles in jar B. Red marble, a circle dot stand for red marbles, and the circle cross stand for blue marbles. If you choose 3 marbles from jar A and another 3 marbles from jar B, what is the probability of getting 2 red and 4 blue marbles? You understand, right? You choose 3 marbles from jar A randomly, and then you choose 3 marbles randomly from jar B. Then, what is the chance of getting 2 red and 4 blue? If you choose 3 and 3 total become 6. Those 6. Out of those 6, 2 red and 4 blue. In which, how many cases? Okay. From 2 jar and 3 from each jar, and then via each jar you have a different kind of marbles. Then we need a table, okay, to analyze. Okay. The possible choices of choosing 3 marbles from each jar is 6C3 and 6C3. From 6 marbles in jar A, you choose 3, so 6C3. Jar B also has 6 only, and then from this 6 you choose 3. So this many different ways total, and that is 6C3 times 6C3 will be 400 if you calculate. The possible choices of getting 2 red marbles and 4 blue marbles are shown below. All possible. Ignore 3 from each jar. Okay, all possible case, and then we choose for the case of our problem. Okay, getting 2 red and 4 blue means from jar A you don't get any but 2 red and 4 blue, and then no red, 1 blue, and 2 red and 3 blue, like that, right? You can write down all possible cases. Of course, we have more on next page, but you look at here. But the problem is, from jar A you have 3 marble, and from jar B 3 marble. But in this case, you have 3 from jar 1, jar A? No. You have 3? No. In this case, from jar 2, you have 6. Okay, so not the case, right? Choosing 3 from each jar. So if you look at over here, which one gave you 3 marbles? This one. From jar A, 3 marble. From jar B, 3 marbles. This is the case, right? So from 3 red, you don't get any. From 3 blue, you choose all 3. And then 2 red, from 2 you choose all 2, and from 4 you choose 1. This one's the calculation method of this case. And when you calculate, the figure come out 4. Okay? And then which one give you 3 and 3? Only 7. Correct? 1 red and 2. I wrote down everything to avoid the missing case. Okay, if you just count like 3 and 3, then probably we may have a chance to miss. That's why I wrote down all possible cases, only terms of 2 red and 4 blue case. 7, 1 red, 2 blue means what? From 3 red you have 1, and from 3 blue you have 2. So 1 red and 2 blue. And then from jar B, from 2 red you have 1, from 4 blue you have 2. Then you have 2 red and 4 blue. The calculation answer come out 108. So here from the table we can choose only 4 and 7 out of all possible combination of 2 red and 4 blue, right? And the next page we have a continuation of 9. Here again. Okay, once we understand, I don't want to go every single case, right? So 3 and 3 will be only 10 here. From jar A we have 3, from jar B we have 3. Then the calculation will be from 3 you have 2, from 3 you have 1, from 3 you have 2, from 3 you have 1. And the same token, okay? From 2 you don't get any, from 4 you have 3. So when you calculate this one, the answer will come out 36. Okay. Okay, look at here again. Number 4, the case was a 4. And number 7, if you calculate 108, 4 and 108. Remember? 4 and 108. And here number 10, when you calculate it was a 36. If you add all these 3 values, you get 148. Okay? All possible acceptable case is 148. Okay? All possible acceptable choice is 148. So probability will be 148 over all possible choice was 400. Remember, 63 times 63 was 100, right? And if you simplify, okay, let's reduce this by 4, then 37. And then reduce by 4, it will be 100. 37 over 100. You cannot reduce anymore, okay? Or if they ask you by percent, then 37%. If they ask you by decimal, then 0.37, whichever. Okay, once you have that, you can change it. No problem, right? Okay, now, for probability questions, you have to remember these three formula. Permutation. What was the permutation? From n, you multiply this many numbers, decreasing 1 each step. N times n minus 1, n minus 2, n minus 3. How many numbers? All numbers. This many numbers. Now, factorial. Factorial means what? From that number all the way down to 1. Then, if you use a permutation symbol, it will be same as NPN. Why? From n numbers, then automatically you will go down to 1. Okay? Each step, take out 1, 1, 1, 1, 1. As you see, right? And the combination. From here, all many numbers, and divided by all factorial. And then probability will be all the time if a statement and then statement. So then statement will be numerator, and then if a statement will be denominator. Okay? Don't forget that. For more practice, go to my website, www.A.durkkim.com. You go to SAT test, and then click SAT 1, and then SAT 1 M81. And there you may have a probability problems a lot. Okay? Okay, thank you. Good luck. Thank you for watching my video. Okay, bye. See you next time.